Hooke's law. Hooke's law was named after the scientist Robert Hooke. Now, who is Robert Hooke? He was born in 1635 in England. He is a natural philosopher, architect, and polymath. His main contributions was the iris diaphragm in cameras, the universal joint used in motor vehicles. The first picture is the original drawings for the universal joint drawn by Hooke that we can see in the second picture, and also the ones that are used in the third picture. Another contribution is the balance wheel in a watch. This component helps to balance and synchronize the hands of the clock. He's the first to use word cell in biology, and his most important achievement is Hooke's law. In this tutorial, we're going to learn how Hooke reached this law and how he did the experimentation that is in figure 2.12 and 2.13. This experiment is made of a ruler that is used to measure the length of the spring, and we have a suspended spring, and at last we have the loads at the end of the spring that are exerting a force on the spring to expand. Now let's watch this video. The purpose of this experiment is to measure the extension of the spring done by the load force. The spring indicator should be placed at 0 on the ruler. Then we start increasing the loads. We notice that the spring is stretching. This expansion is measured from the point 0. The extension of the spring is equal to the stretched length minus the unstretched length. The stretched length is the measurement, the final measurement of the spring on the ruler. The unstretched length is the length that the spring started with, the initial state length. After he was done, he used these data to draw a graph between the force and the extension. So to draw this graph, all we have to do first is naming the x-axis and the y-axis. On the x-axis we have the extension and the unit is meters, and on the y-axis we have load force and the unit is Newton. We notice that we get a straight line passing through the origin. So this means that the law of elasticity, which states that the stretching of a solid body is proportional to the force applied to it. We have a point that is called the elastic limit. It is the point at which the spring reaches its maximum length, maximum extension before it loses elasticity. If the spring is stretched beyond this limit, then the change in shape is permanent. In this case, Hooke's law is not applicable. We can see in this graph how the elastic limit is represented. We have this point here, and from this point on, the spring is no more elastic. So here we can say that this is the maximum extension of the spring before losing its elasticity, and the maximum force applied before losing spring's elasticity.